This video is on using the ratios to find a missing side. And this particular video will be on when you find x on the bottom, or the variable on the bottom. So I hope you've had a look at 2A and managed to have a crack at a few of those questions, because this video builds on a few of those concepts. So you'll notice on the top right hand corner the 5 steps that I mentioned in the previous video. We're going to use those 5 steps again to solve these trigonometric equations. So a typical question would be something as you've seen right there, and the question, the prompt would be solve for x. So the first step is draw the triangle. We've done that. Next step, label H, O, and A. So let's go to our reference angle. Our reference angle's right there, and it's 43 degrees. So we're going to label the triangle as H, O, and A. Now, this next step might be a bit confusing. This next step might have you wondering, well, what do I even do now? Which ratio do I even choose? Because I'm not told which ratio to use. What you need to do is you actually need to have a look at which pieces of the puzzle you're given. So, out of the H, O, and A, which ones do we actually have values for? Or which ones can we use? So let's label this H equals, O equals, A equals. In this case, H equals X, O equals, well, we don't have anything there, so I'm just going to leave it as blank, and A equals 52. So if you want to use a ratio to solve this question, we need to have a look now. What two pieces do we have? We have a value for the A, and we have a value for the H. Despite the fact that it's an X, we still have a value for it. So if you look at our SOHCAHTOA, A and H, that falls under Ka, which means that we can use C, or in other words, cos, to solve this equation. So let's write it down. Cos theta equals adjacent over hypotenuse. Which ratio do we use? That one. Now let's substitute the values in. So in this case we've got cos, the angle that we have is 43, and the adjacent side is 52. Sorry, my mistake, that's supposed to be 52. And the opposites, apologies, the hypotenuse is x. So you can see with this particular example, x is on the bottom. How do we solve this? Well, there's a little trick that you can use whenever a variable is on the bottom. And this goes by saying that we're just going to swap the positions of those two variables. So this will end up being x equals 52 over cos 43. So just as a side example here, if you had something like sine 50 equals 20 over x, all you would need to do here is just swap those two values. So this would become x equals 20 over sine 50. Okay, but don't worry about that at this stage because that's not part of the question. So after you plug this into your calculator, you should get a value of x equals 71.10. So in this case, x equals 71.10. Alright, so this next example that we have, as you can see here, it follows the same procedure. Let's take it step by step, but before we do that, I'd like you to pause the video right now, follow the 5 steps, and attempt the question on your own. Alright, now that you've given it a shot, let's try this question out. So draw the triangle, completed. Label H, O, and A. So this is going to be the 90-degree angle. This will be our H value. This is our reference angle, which means this is the opposite, and this is the adjacent. Which ratio do we use? Well, with the previous question it's a bit different, but here it's actually explicitly told us to use tan. And if you remember what tan is equal to TOA, which means tan theta is equal to O over A. Done. We'll substitute the values in. So what we have is 10, 22 equals 16 over x. You can see with this example, x is on the bottom. So again, we switch. This becomes x equals 16 over 10, 22. And here is when you start putting into the calculator, and you should get a value of 39.6. That's rounded off. Now let's look at this next question. It's a worded question, so let's decipher what we know from here, so that we can apply trigonometry to this. Sorry, just going to move the screen down. Jack is flying a kite at the local park. He lets out 50 meters of his kite string, which makes an angle of 62 degrees with the ground. Calculate the height of the kite above the ground to the nearest tenth of a meter. So let's work out the situation. Let's just say Jack is standing right here, and he's got a kite. He's holding a kite. So he's holding a kite, and this kite is 50 meters long. And it says here it makes an angle with the ground. Let's just pretend at this stage right here, that's the ground. The ground, he makes degrees of 62 degrees. And we want to work out from this kite, what is that value? So, let's draw this triangle a bit more accurately and enlarged. So this becomes 62, this becomes x, and this is 50 meters. Now, first step, draw the triangle. That was the absolute that's the absolute important step in this particular example, because if you don't draw the triangle, you don't know what you're actually looking for. So draw the triangle, complete. Label H, O, and A. This is going to be O. I'll use another pen, sorry. This is going to be O, this is going to be H, and this will be A. So like the previous question, let's just go H equals, O equals, A equals. Now, what's the value for H? 50. What's the value for O? X. What's the value for A? We don't have one. So what two pieces of the puzzle do we have? We've got the O and we've got the H. Now, O and H, if you remember, that's SAW. So sine theta equals O over H. Which ratio do we use? Done. Now let's substitute the values in. It's just a matter of reading from the question. This becomes sine 62 degrees is equal to O, which is x over H 50. Now, from here, what we have is a particular case where we don't actually have x on the bottom. So if we don't have x on the bottom, it's just a matter of multiplying at the front. So this becomes 50 times sine 62 equals x. So in this case, if you plug that into the calculator, you should get a value of, sorry, just typing into my own calculator, 50 times sine 62, just get a value of 44.14. 17, sorry. Sorry, I do apologize. This is supposed to be 44.15. In other words, this becomes, when you round it off, x equals 44.2 meters. So just to contrast these two different types of examples, you have one where x is on the top, you can see there, and all we need to do is multiply by that bottom number. And if you look at the previous slide, you can see x is on the bottom, so it's just a matter of swapping to find what the value of x is there. See you in the next video.